हरिः कर्ता।
So now it's time to move on to the next step under data acquisition. That's pre-data cleaning. So why do we call this a pre-data cleaning? So this the main data cleaning will be done in pre-processing step of overall data science process, but here we will do the pre-data cleaning. So we will try to handle missing data, outliers, and dealing with the duplicates, whereas the actual data cleaning technique where we'll have a more understanding about the data set than compared to it's mainly done by the data scientists, where they'll have a clarity of the data sets of what is missing data. So what at how far we can go to tell this is outlier, this is not the outlier. So at this moment the bare minimum or the fundamental things will be handled under this pre-data cleaning by the data engineers. Basically this data acquisition will all be done, the first step will be done by the data engineers, and in most of the companies. But if you work under the service based companies or small companies where you have to the data scientist handle the overall procedure from data acquisition till optimization, even the deployment case. But normally it's not the case. So you will be taking over from data cleaning, EDA, then you'll go for the feature engineering, then the rest of the things will fall into the place one by one. But however, if you work under the small scale company, then you might need to do this. So that's the reason we are discussing what all techniques that we can use here. So anyway, let's get into the pre-data cleaning. So okay, let me do that. The first one, we will try to figure it out, the missing data. So once we found the missing data, then we can handle the missing data. The first category of techniques under this is handling missing data. Basically we use imputation techniques. Okay, first let's get into the action one by one. Okay, so now let's load the data set. So data is equals to pandas dot read csv, then okay, so that's what is our data set. And two dunders, then it's let me print data and let me see. Yep. Here you can clearly see there is a nan, and there are duplicates. I think it seems there are outliers and all, but let's as this data is smaller, you can figure it out by just looking at. But if the data size increases, then you have to use the techniques from the Python. So let's do that. First, let's figure it out. Let's check for the values. Let's try to figure out the uh, missing values. So check for missing values. Okay, so print data dot is null, data dot is null. Then after that what we have is sum, and let me see that. Okay, so total we have 3 columns, and out of the 3 columns you got temperature 0 nulls, and humidity you have 1 null, and growth rate you have 2 nulls, and that's what you can see here also. So that's what, so we have figured out the nulls, and now we have to handle the null. How do we handle the null? Okay, to handle the nulls, what we can do here is we can use imputation techniques. So here we'll be discussing about only one imputation technique when it comes to actual data cleaning process of data science, data cleaning step of data science process. So there I will explain each and every imputation technique, but for now let's use mean imputation technique. So So impute missing values with the mean. So impute missing values with the mean. So data, and let me put the column name. Our column name, let's say this one, it's a growth rate. That's what the first target for me. Let me go for the growth rate. So growth rate, and I'm gonna use a fill NA, fill null. Yep. So data, and I have to check the column name. That's again growth rate, and I have to use a mean imputation technique and do it in place. Do it in place. Okay, and let me attach a name to this, growth rate imputed. Yep. So here is that growth rate imputed technique. The growth, it's been imputed. You can, let me check that, and here is that all NA values become 0. The 2 on null has become 0. Okay, can you see that? It's basically a mean imputation technique. So this is how we do the imputation technique. So next we'll go for the outlier detection. We'll handle the outlier detection here. So we can use basically a box plot to detect the outliers. We will use the same data set. So this is the data set that we are going to use, where the missing values has been filled up. So out of that, so I'm going to use a growth rate. Yeah, this is what my series I'm going to use. So let me import matplotlib dot pyplot as plt. So fig comma x is equal to plt dot subplots. Yeah, so this is what my subplot, and here I'm gonna do it. So x, and it's a box plot. So if we just want to check what I can give in the box plot, I'll give x, and so if you just want to customize anything else, you can customize. For me, just giving the value of x is more than enough. So x is equals to, and let me call up, and so I can find out plt dot show. Okay, I can clearly figure it out. There are some missing values. So this is your box plot. So this 1 2 3 4, so the one value which is above 4000 is the one which is missing. So okay, this one 4500, and the second value which is between 1000 and 2000, so that's this one 1000. Okay, another one 199 to, so total 4 values are outliers of this whole data set. You see that, because the remaining data set is by and large between 2 and 4.7, but uh, you can clearly see there the remaining data points which are between 2 to 4, but the 4 data points which are very higher, between 145 to 4000, and these are the outliers, and this is how we detect the outliers using box plot. And similarly, you can use a g-score, and those things we'll be looking into those things in detail in actual data cleaning step of the pre-processing. Okay, so now let's look into the dealing with duplicates. Okay, So the third step, which is dealing with duplicates. So as usual, let's import pandas as pd. Then let's load the data set again. You got the same data set. So pandas dot read csv, and that's it. Your data set has been loaded. Now let's check for the duplicates. Obviously we have to check for the duplicates. Let's check for the duplicates. So let me print it. Print data dot, we have to say duplicated, and sum of. So we have only one duplicate, we know that, but before that let me print data also. Yeah, and they're saying there is only one duplicate, that's one. So that could be that, you can figure it out. And 30 and 32 there look similar, so there, that row has been duplicated. That's what it's trying to say. It's trying to say. Okay, so now I need to remove, because I have identified I have identified the duplicates. Now I need to remove the duplicates. So let me remove duplicate records. So data dot drop, and I need to drop duplicates. So in drop you will have various methods. You can drop NA, drop level, drop, and then drop duplicates. Let me go for the drop duplicates. So I need to do it in place, and true. And here you would have found the duplicate has been. So here you see that data dot duplicate. Okay, so data drop duplicates, and now let's verify the updated data set. So let's verify the updated data set. So print data set again. That's it, it's gone. So before it was 32, this is the one which is duplicated, and that one it's gone. Now you have only 31 rows. So these examples provide a starting point for handling missing data, outliers, and duplicates. So depending on your specific data set and requirements, you may need to explore additional techniques or methods for more robust data pre-processing and cleansing.